Dear students, today's topic is Pauli's exclusion principle. കഴിഞ്ഞ ക്ലാസ്സിൽ ക്വാണ്ടം നമ്പേഴ്സ് ഏതൊക്കെയാണെന്നും അതിനെക്കുറിച്ച് വിശദമായിട്ട് പഠിച്ചു. ഒരു ആറ്റത്തിൽ ഒരു ഇലക്ട്രോണിന്റെ സ്റ്റേറ്റിനെ റെപ്രസെന്റ് ചെയ്യാനായി പ്രധാനമായും 4 ക്വാണ്ടം നമ്പേഴ്സ് ആണ് ഉപയോഗിക്കുന്നത്. ഫസ്റ്റ് വൺ ഈസ് ദ പ്രിൻസിപ്പൽ ക്വാണ്ടം നമ്പർ ആൻഡ് is represented by n. And the second one is the orbital quantum number represented by L. And the third one is the magnetic orbital quantum number represented by Mn. And the fourth one is the magnetic spin quantum number represented by Ms. Principal quantum number n എന്നത് ഒരു ആറ്റത്തിലെ ഏത് ഓർബിറ്റിലാണ് ഒരു ഇലക്ട്രോൺ ഒക്കുപൈ ചെയ്യുന്ന എന്നതിനെ റെപ്രസെന്റ് ചെയ്യുന്നു. ഓർബിറ്റൽ ക്വാണ്ടം നമ്പർ L ഒരു ഓർബിറ്റിന്റെ ഷേപ്പ് അതിന്റെ സൈസിനെ റെപ്രസെന്റ് ചെയ്യുന്നു. ഇനി ഒരു ഇലക്ട്രോൺ ഏത് സബ്ഷെല്ലിലാണ് എന്നതിനെയും ഓർബിറ്റൽ ക്വാണ്ടം നമ്പർ റെപ്രസെന്റ് ചെയ്യുന്നു. ഓർബിറ്റൽ മാഗ്നറ്റിക് ക്വാണ്ടം നമ്പർ Ml എന്നത് ഒരു ആറ്റത്തിലെ ഓർബിറ്റ്സിന്റെ ഓറിയന്റേഷനെ റെപ്രസെന്റ് ചെയ്യുന്നു. അതായത് ഒരു ആറ്റത്തിലെ ഓർബിറ്റ് ഓറിയന്റേഷൻ ക്വാണ്ടൈസ്ഡ് ആണ്. Then the magnetic spin quantum number എന്നത് ഒരു ആറ്റത്തിലെ ഇലക്ട്രോണിന്റെ സ്പിൻ ഓറിയന്റേഷനെ റെപ്രസെന്റ് ചെയ്യുന്നു. അതോടൊപ്പം തന്നെ ഇലക്ട്രോണിന്റെ സ്പിന്നിനെ റെപ്രസെന്റ് ചെയ്യുന്നു. That is, the principal quantum number n gives the position of the electron in the principal energy level, and L gives the size or shape of the orbital, and Ml the orientation of the orbital, and Ms the spin of the electron. Thus, the state of an electron in an atom can be specified by these 4 quantum numbers n, L, Ml, and Ms. These 4 quantum numbers can be related. That is, for example, if we consider the value of n as 2, n2 means that electron is in the second orbit. Then, if n is equal to 2, then L can have values from 0 to n minus 1. That is, L can have values 0, 1. That is, L can have values 0 and 1. Then the value of Ml depends on L. That is, for a given value of L, the Ml can have value from minus L to plus L. Therefore, Ml can have value from that is 0, 1, minus 1. And similarly, the Ms can have values only plus half and minus half. That is, the value of n, L, Ml and Ms are related. For a given value of n, L can have value from 0 to n minus 1. And Ml can have value from minus L to plus L. And Ms have only 2 values, plus half or minus half. So consider a case in which an atom contains only 2 electrons. And these 2 electrons are in the first orbit. The first orbit means the value of n is 1. And then we can consider the quantum numbers n, L, Ml and Ms for these 2 electrons. For the first electron, n is equal to 1, and for the second electron, n is equal to 1 because both electrons are in the first orbit. Then L can have value, if n is 1, L can have value 0. And for the first electron, this Ml can have value 0. And the Ms can have only 2 values. For the first electron, it is plus half. And then for the second electron, n can have value 1 and L can have 0 and Ml is 0 because n is 1. But the Ms should not have plus half value. It should have minus half value. That is, if these 2 electrons have all the quantum numbers same, then the atom itself exclude 1 electron from that atom. Here, the 2 electrons, they have the 3 quantum numbers same. N, L, Ml values are the same, but the fourth Ms value is different for the 2 electrons. And for the first electron, it is plus half, and the second electron, it is minus half. But if the second electron also have the plus half value, then the atom would exclude that electron from entering into the constitution of the atom. And this is what is the Pauli's exclusion principle says. That is, according to the Pauli's exclusion principle, no two electrons in an atom can have all the same set of 4 quantum numbers, or no two electrons in an atom can have the same set of 4 identical quantum numbers. That is the Pauli's exclusion principle. And if the two electrons have all the same set of 4 identical quantum numbers, then the atom itself excludes that electron from entering into the constitution of that atom, and hence the name exclusion principle. That is, if an atom contains 2 electrons having the same set of 4 identical quantum numbers, then the atom itself excludes this electron from entering into the constitution of the atom. That is the exclusion principle. That is, if the 2 electrons do have all their 4 quantum numbers identical, then one of these 2 electrons would be excluded from entering into the constitution of the atom. Hence the name exclusion principle. And we can consider a simple pictorial representation of this exclusion principle. That is, for example, in the case of helium atom, the two electrons cannot be oriented in this way, because here both the electrons have the spin in the same direction, and here also they have the same direction. It is not allowed. These two cases are not allowed, and the electron should have one electron should have a plus half sign, then another one should have a minus half spin. That is the correct way. According to this principle, the maximum number of electrons that can be included in each shell can be calculated. That is, the principal quantum number n, the orbital quantum number L, the magnetic orbital quantum number Ml, and the magnetic spin quantum number Ms, and the total number of electrons. For the K shell, that is, n is equal to 1, and n is equal to 1, L can have value 0, and when L is equal to 0, Ml is 0, and the Ms value have plus half or minus half. That is, the NL, Ml and Ms value of the electrons are 1, 0, 0 plus half for the first electron. For the second electron, 1, 0, 0 minus half. That is, for the K shell, there are 2 electrons. And for the second shell, L shell, n can have 2. Then when n is equal to 2, L can have value 0 and 1. And here S represents the subshell. The subshell corresponds to L is equal to 0, S subshell. The shell corresponds to L is equal to 1, P subshell. When L is equal to 0, Ml is equal to 0, and the Ms can have value plus half and minus half. Then the electron quantum numbers are 2, 0, 0 plus half for the first electron, 2, 0, 0 minus half for the second electron. That is, the 2 electrons can have these values. Then the remaining electrons having L is equal to 1, or in the P subshell, the N, L, Ml and Ms values are 2, 1, 1 plus half for the first electron, 2, 1, 1 minus half for the second electron, and 2, 1, 0 plus half for the third electron, 2, 1, 0 minus half for the fourth electron, and 2, 1 minus 1 plus half for the fifth electron, and 2, 1 minus 1 minus half for the sixth electron. That is, the total number of electrons in L shell is 8. And considering the M shell, for the M shell, n can have value 3. Then corresponds to n is equal to 3, L can have value 0, 1 and 2. And when L is equal to 0, Ml is 0, and the quantum numbers are plus half and minus half. And when L is equal to 1, Ml can have 1, 0 minus 1, and the spin will be plus half or minus half. And when n is equal to 2, L is equal to 2, it corresponds to D subshell, and the ML can have value plus 2, plus 1, 0, minus 1, minus 2, and the spin values are plus half or minus half. And here in the first case, that is the NL, ML and MS value are 3, 0, 0 plus half correspond to 1 electron, 3, 0, 0 minus half correspond to the other electron, that is the 2 electrons. Then other one is 3, 1, 1 plus half. Then for the second one, 3, 1, 1 minus half. And third one, 3, 1, 0 plus half. And the fourth one, 3, 1, 0 minus half. And for the fifth one, 3, 1 minus 1 half. And 3, 1 minus 1 minus half. That is total 6 electrons. And for this L is equal to 2 values, the quantum numbers are 3, 2, 2 plus half, and 3, 2, 2 minus half. Next 3, 2 plus 1 plus half, and 3, 2 plus 1 minus half. That is 4 electrons. Then the fifth one is 3, 2, 0 plus half, and the sixth one is 3, 2, 0 minus half. And next one is 3, 2 minus 1 plus half, and 3, 2 minus 1 minus half. Then the 3, 2 minus 2 plus half, and next one is 3, 2 minus 2 minus half. That is total 10 electrons. That is in the M shell, the total number of electron is 2 plus 6 plus 10, that is 18 electrons. That is in the K shell there are only 2 electrons, and in L shell there are 8 electrons, and in M shell there are 18 electrons. And these electrons are arranged according to the Pauli's exclusion principle. That is the Pauli's exclusion principle.